What if a secret audio message could be hidden anywhere? In a letter, or on a poster, on a sticker on a park bench, or even spray painted on a wall, and you could actually hear that message. Listen to what I got in the mail today.
Meet at the bridge at midnight.
That voice was hiding inside this picture. I like to call this a spectrogram cipher. And today, I'm going to show you exactly how to make one and how to decode it. Now, think about what you could do with this. For example, a treasure hunt where each clue is a printed spectrogram leading to the next location. Or an escape room where a framed picture is actually a voice giving you the combination. Or street art that has an impactful message for anyone who knows how to listen. Or a letter to a friend with a personal message they'll never forget. Or a classroom project where students encode and decode messages from each other. Or an ARG where a mysterious voice reaches players through printed images scattered across the city. The ways you can use this tool are really just limited to what you can imagine. This is a medium nobody's really explored yet, and the tools are free right now, waiting for you to use. We're going to use a tool that I built called ReSounder. ReSounder is completely free. It's open source on GitHub, has no ads, no login, no tracking, and it runs entirely inside your browser. Nothing ever leaves your computer. My goal with this video is simply to show you what this tool can do and get you excited enough to try it yourself. So let's go. Now, if you've ever used audio software on a desktop, you've probably seen a spectrogram before. It's just a visual way of looking at sound. The vertical axis is the frequency from low to high, the horizontal axis is time, and the brightness or color at each point tells you how loud that frequency is at that moment. When you talk, sing, or play music, you're creating a complex pattern of frequencies that change over time, and the spectrogram captures that pattern as an image. If you want the deep dive on the math behind ReSounder, let me know in the comments and I'll make a video about it. For now, let's just use the tool. Alright, let's make the spectrogram cipher I played at the beginning of this video. I'll walk through this step by step so you can follow along if you want, or you can just watch and get the idea. To make a spectrogram cipher, we need a spectrogram. And for that, I use another free tool I built called SpectroGhost. SpectroGhost is a general purpose spectrogram creator, but it has a feature that makes it especially good for this. It can produce spectrograms optimized specifically for ReSounder. I originally built SpectroGhost because I wasn't sure how precise a spectrogram needed to be in order to get good audio back. Turns out ReSounder is pretty forgiving. So if you prefer a different audio app to make your spectrograms, you can absolutely try that too. Okay, let's open SpectroGhost. We need some audio. We could open an audio file, but I'm just going to hit record and just say something into the microphone. Meet at the bridge at midnight. When I stop recording, SpectroGhost generates a spectrogram at the bottom of the page. There are only a few settings I'm going to change for this example. The FFT size is set to 2048 by default. For speech, somewhere between 1024 and 4096 hits the sweet spot from my ears. Next is maximum frequency, which I'm going to set to 5000 Hertz. Human speech doesn't have much going on above 5000 Hertz, and I don't need the extra height. But if you're encoding music, you might want to push this a little bit higher. And for voice, I wouldn't go below about 4000 Hertz or things start to sound a little muddy. Then just click Optimize. This button does something really clever. It calculates the ideal image dimensions so that every pixel maps 1-to-1 to the actual frequency data. So there's no wasted space and no interpolation that's needed. It also embeds metadata in the PNG so that ReSounder can automatically configure itself when it opens the file. One setting worth experimenting with, though, is overlap. This is the overlap between analysis windows. More overlap means smoother transitions in the reconstructed audio. Less overlap means sharper, more robotic sounding output. The default is 75%, and that's a good starting point. Then click Export PNG, and that's it. You've got your spectrogram cipher. Save it somewhere you can find it. Now let's flip to the other side. Open ReSounder and click Choose File. Select the PNG that we just exported from SpectroGhost. Watch what happens. ReSounder reads the metadata embedded in the image and automatically fills in every setting. The FFT size, sample rate, frequency range, duration, color map. You don't need to touch a thing. Now, before we click this next button, I'll give you the same warning ReSounder gives, which is to turn down your speakers. The first time you do this, you don't know how loud it's going to come out. Then just click Invert Spectrogram.
Meet at the bridge at midnight.
Did you hear that? We just turned audio into a picture and then back into audio. Think about what that means. Anywhere you can put an image, you can now put something people can listen to, which is so awesome. Now, when you send a spectrogram cipher to someone, if they're opening the original PNG exported from SpectroGhost, the metadata handles everything. They open the file, click Invert Spectrogram, and they're done. But what if the spectrogram was printed or screenshotted or photographed off a wall? The metadata is gone. They're going to need a few critical pieces of information to get intelligible audio out of ReSounder. And this is where you, as the puzzle creator, might want to give them some help. So these are the critical settings. First is the sample rate. If this is wrong, everything comes out at the wrong pitch. Next is FFT size, and this needs to match what you used in SpectroGhost. If this is wrong, the audio sounds either robotic or like someone's talking through a fan. 2048 is a safe default. Next is the maximum frequency, which if this is wrong, the pitch will be off. This also should match what you set in SpectroGhost. Spectrograms will often display the frequency range on the vertical axis, so if you're looking at spectrograms online, then look at the numbers on the vertical axis for this. You can also play around with the logarithmic axes, but for voice audio, a linear axis works just fine. Finally, duration. They need a rough estimate of how long the audio is. If the duration is too short or too long, they may not be able to understand the speech. Spectrograms will often display the duration on the horizontal axis. How you communicate these parameters is part of the puzzle design. ReSounder also has a tips for getting good results section that walks through common problems and fixes, so a determined solver can figure it out through trial and error. Making a physical copy of a spectrogram is where spectrogram ciphers really come alive. This is where you turn digital audio into something physical, which is so awesome. Before you print, here are a few quick tips. First, I would recommend adding a border. This just gives the decoder a clean edge to crop to, which matters more than you might think. A slightly rotated or skewed photo can distort the audio reconstruction. Next, choose your color map wisely. Grayscale is the safest bet for printing because it only needs black ink and it scans or photographs cleanly. Color shifts from printing will change how ReSounder interprets the magnitudes. Finally, print at high resolution. The more detail in the print, the better the reconstruction. Now, when someone receives your printed spectrogram, here's their workflow. First, they're going to need to photograph or scan it. A flatbed scanner is ideal, but a phone camera works. Try to get it as straight and evenly lit as possible. Next, they need to open it in ReSounder. They'll choose the photo file or take a picture directly using ReSounder's camera button. Then they use the image adjustments panel. This is the key to working with photographs as spectrograms. ReSounder has built-in tools for exactly this situation. After the image looks good, they'll need to enter the ReSounder settings manually. Since the metadata is gone, they'll need to type in the sample rate, FFT size, max frequency, and duration. This is where any hints from the puzzle creator come in handy. Finally, they'll just click Invert Spectrogram and listen.
Meet at the bridge at midnight.
The quality won't be as crisp as decoding the original digital file, and they may need to play around with the settings before they can make out your speech. Printing and redigitizing introduces noise and distortions, but for speech, it works. The message comes through, and there's something genuinely awesome about pointing your phone at a piece of paper and hearing a voice come out of it. It's so cool. Okay, if you're gonna start making spectrogram ciphers, here's my short list of best practices for creators. First, keep your message short and clear. Long messages will work, but shorter ones reconstruct more cleanly and are more impactful. Second, use SpectroGhost's Optimize button. Third, stick with grayscale for printing puzzles. It survives printing, scanning, and photography better than color maps. Fourth, test the full loop before distributing. Create the spectrogram, print it, photograph it, and decode it for yourself. If you can't get good audio back, your audience won't either. Fifth, think about the delivery. The medium is part of the message. A spectrogram tucked inside a wax-sealed envelope feels different than one plastered on a telephone pole. Sixth, give your players a breadcrumb. A QR code linking to ReSounder, or a URL printed in the corner, or something that gives them a clue as to how to decode this and what they're going to do with it. Let the challenge be the content of the message, not the mechanics of decoding it. If you build something with this, I really want to see it. Post it in the Discord, tag me in the comments, or send it to me in the mail. Seriously, send it to me in the mail. And if you're a developer and want to fork ReSounder or SpectroGhost and build something custom, it's all open source on GitHub, so go for it. If you enjoyed this, hit subscribe and drop a like so that I know to make more content like this. And if you want to get started right now, the links to ReSounder and SpectroGhost are in the description. Also, hop into the Clue Discord if you want to connect with other puzzle builders and solvers. If there's a cipher type or puzzle technique you want me to cover next, tell me in the comments. If enough of you ask, I'll make a video on it. And honestly, if I don't already have a tool for it, I might just build one. Until next time, stay curious, stay relentless, and keep decoding.